Dear students, in the last video of this chapter, you learned about induced magnetism. In this video, you are going to discuss about electromagnetism. From the title itself, you can understand that it is related to electricity and magnetism. To understand more about electromagnetism, let's do an activity. The following items are required for this. A 2 into 1.5 volt batteries mounted in a battery cell holder which is connected to the crocodile clips, a magnetic compass, a copper wire of 10 cm, a cutter and a bar magnet. Take the copper wire and remove the insulation at its end by using a cutter. Connect the ends of the copper wire to the crocodile clips that are already connected to the battery. Now move the wire over the compass. Do you see the needle of the compass deflecting when the wire is brought near to the compass? This is same like as when you bring a permanent magnet near to the compass. So, the copper wire has become a magnet when electricity is passed through it. The copper wire becomes a magnet because of electromagnetism. Electromagnetism is produced when an electrical current flows through a simple conductor such as a length of wire or cable. As current passes along the whole of the conductor, then a magnetic field is created along the whole of the conductor. The magnetic field created around the conductor has a definite direction with both north and south poles. The direction of this magnetic field is determined by the direction of the electrical current flowing through the conductor. The magnetic field around a current-carrying conductor. The diagram shows the field pattern caused by a current flowing in a wire. You can see that the magnetic field lines are in the form of circles, and that also they are having common center. We said that the direction of magnetic field around a current carrying conductor is decided by the current flowing through it. Therefore, the direction of the field is clockwise when viewed in the direction of the current. If the current is reversed, then the magnetic field also reverses. You can also notice that the strength of the magnetic field is greater at the center or closer to the wire and gets much weaker as you move further away. Now let's see how we can increase the strength of this magnetic field. One way of making a stronger magnetic field is to wind the wire into a coil. The wire winded like this into a coil is called a solenoid. This is the diagram of solenoid. When the ends of the solenoid are connected to the battery, the current will flow through it. When a current flows in a solenoid, the magnetic field just looks like that of a bar magnet. Magnetic field can be made stronger by increasing the current flowing through it, making more loops of wire with the same length of the wire, putting a core of iron or steel inside the solenoid. Next, we are going to discuss about electromagnets that work on the principle of electromagnetism. An electromagnet is a magnet that runs on electricity. We can create a simple electromagnet at home as shown in the diagram. Wind a piece of copper wire around an iron nail. Connect the ends of the copper wire to the battery. When current flows through the wire, your electromagnet is ready. Unlike a permanent magnet, the strength of an electromagnet can easily be changed by changing the amount of electric current that flows through it. The poles of the electromagnet can even be reversed by reversing the flow of electricity. These electromagnets are used in many domestic and industrial devices. They are used for lifting, sorting, and moving metal objects. For the electromagnets to do all these power jobs, it needs to produce a very strong magnetic field. To make this happen, the electromagnet have a coil of copper wire wound tightly around an iron core. The purpose of using iron core is that it makes magnet 2000 times stronger than the same solenoid having air in its center or core. When the current in the coil is switched on, the solenoid becomes a magnet. Due to the presence of magnetic field of the solenoid, the iron will get magnetized by induced magnetism. This produces a strong magnetic field than the solenoid of its own. Another advantage of using iron is that as it is a soft magnetic material, it will lose magnetism as soon as the current is turned off. This is required because electromagnet is a temporary magnet. As I told before, there are many uses for electromagnets. One among them is the separation of magnetic materials from non-magnetic materials. Electromagnets are used to separate magnetic metals like iron and steel from non-magnetic metals like copper and aluminium. They are also used in many other electrical devices like loudspeakers, relays, and circuit breaker. Let us understand the function of electromagnet in each of them one by one. Loudspeaker. Speakers come in all shapes and sizes, enabling you to listen to music on your iPod, enjoy a film at the cinema, or hear a friend's voice over the phone. It is an electronic device that converts electrical energy into sound energy. Inside the loudspeaker, there is a cylinder-shaped permanent magnet. This produces a strong magnetic field. There is an amplifier connected to the speaker that sends out an alternating electric current. In front of the permanent magnet, there is an electromagnet. Inside a speaker, an electromagnet is placed in front of the permanent magnet. As pulses of electricity pass through the coil of the electromagnet, the direction of its magnetic field is rapidly changed. This occurs as alternating current is passed and the current changes its direction. When there is change in direction of current, the direction of magnetic field also changes. Because of this, there is a continuous push and pull on the permanent magnet. This makes the coil move in and out. The push and pull is caused by the interaction of both the magnetic field of permanent magnet and electromagnet. This means that the electromagnet is in turn attracted to and repelled from the permanent magnet, vibrating back and forth. Due to this, the cone of the loudspeaker also vibrates and amplifies and strengthens the signals. These vibrations travel through the air to your ears and detect them as sound. Next electronic device that make use of electromagnet is relay. A relay is a switch controlled by electromagnet. It uses a small current to switch on a separate circuit which may carry a larger current. This is the circuit diagram of relay used to turn on the starter motor of a car. There are two circuits, input circuit and output circuit. Input circuit consists of an ignition switch. It is a switch by means of which the engine of a motor vehicle may be started or stopped. This switch is turned on or off when you try to start the vehicle using the key. The input circuit have an electromagnet which is attached to an iron lever. The output circuit contains two contacts and power supply to the starter motor. When the ignition switch is turned on, current flows through the electromagnet from the battery and the solenoid will turn to the electromagnet. This electromagnet attracts and pulls the iron lever. When the iron lever is pulled on, contacts get closed, allowing much larger current to pass through the starter motor. Now the vehicle will get started. If this larger current flowed the wires of the ignition switch, it will melt them. You can see electromagnets in circuit breakers also. We have already studied about circuit breakers in the previous chapter, electricity. It is an automatic safety device found in many homes. Do you remember the function of a circuit breaker? It was, if the current in a circuit gets high, then the circuit breaker will cut the circuit off. Let's see how a circuit breaker works. This is the circuit diagram of circuit breaker. It consists of two contacts, a reset button, iron catch, and electromagnet. An electric current is given to the circuit breaker that flows through the electromagnet as well as through the contacts. You can see a spring that is trying to pull the contacts apart. But there is an iron bar with a catch attached to the contacts which stop them from separating. When the current passes through circuit gets too high, the strength of the electromagnet increases. This in turn pulls the iron bar towards the electromagnet. When the iron bar gets attracted to the electromagnet, the two catches are separated and released. Now it's easy for the spring to pull the contacts apart. When the contacts are separated, the current will not pass through them to the device. This is how a circuit breaker ensures the safety of an electrical device. Another use of electromagnetism is the recording and storing of data. Magnetism has become very important in the modern world for storing information. Magnetism is used to record sound on iPods, to record pictures on hard disk drives, to record data on computer disk, as well as nowadays Credit card and cash dispenser cards have magnetic strip which stores the details of the cardholder's bank account. So these all are the uses of magnetism. Students, this was the last part of the chapter Magnet and Electromagnets. Throughout this chapter, we were discussing about permanent magnets, electromagnets and their properties. You also learned about theory of magnetism and electromagnets. You explored more about the uses of electromagnets. Thus, we have completed the syllabus for second term. This was a new experience for you to learn through distant education. Hope you all enjoyed and understood the classes. Thank you so much for listening and watching the videos. Thank you.